Hello everyone. Today we're going to talk about Apache Hive data units. What are data units? What is it about? What kind of data units Apache Hive offer us and how we're going to use it. So let's take a look at that. The first thing, Apache Hive have many data units. In it, there are databases, there can be tables, there can be partitions, there can be bucketing, there can be skew keys. So these kind of thing we're gonna look into that, and we will tell you about a brief introduction about that, and then we will see how it's gonna store on HDFS. So what is databases? Databases in normal RDBMS is a container. Here databases is also a container which contain number of different objects, tables, partitions, view, and columns. Number of things it can accumulate in it. But these are called object. But here's is more appropriate, you can say databases are the containers. So its major impact is that you can segregate things in it. If you did not give any location while creating database, then you create a table without a location. It will go to Hive temporary location, which is managed table is being called. We will study managed table and unmanaged table in upcoming session. Database can help you enforce security because the group of units under it or group of objects under it can implement it with the security. It will be very helpful putting the security through Ranger specifying databases. So this is the purpose of databases. The second data unit of Hive is tables. Is the homogeneous unit of data which have same schema. It contains rows in it, which means that every row will have the same schema. That's why it's called same schema. So if we take a look at that, inside it, there could be columns. One column will contain the same data type data in it in different rows. But one column data type can be different with other column data type. Like take an example that user ID can be big int. Timestamp is an int and behind the scene it's stored as an int. Although if whatever you want to store in a timestamp, it will cross-bound as an integer behind the scene by Hive. So there are web URL which is string data type and email is string data type. So that means Hive does support the data type. We will study data types in a separate session. So let's move to next data unit. Next data unit, partitions. Partitions is a part of table data unit. Inside table, there can be one or more partitions. It is usually used to store the data, and it's help us to execute efficient queries because against a partition, row will be distributed and data will be distributed and stored. And once you run a query specifying partition, optimizer will instruct the mapper and reducer to use the partition specified in the query, and it will help in faster execution. We have an example here. It specifies the partition on date and country. And if you specify the partition on date, which is a base partition, and inside in it, there is a country partition. So with what it's gonna be doing that with every date, there will be a second partition will be created with country data as well. So that's segregate the partition at two levels. So this is the purpose of partition. Let's move to next one. And just to remind last thing that partition columns are virtual column. This is not the part of data. Whatever you specify while loading data into table as a partition name, it will virtually that data is attached for that partition. So let's move to next data unit, which is bucket. Bucket is being used inside partition. So you have table, then table is being distributed within partition, and partition is being distributed inside in it with a bucket. So bucket is subdividing the partition in it to execute fast queries. So that is one use case for it. So bucket or cluster both are the same thing. So that is how bucket is being used. Next data unit is skew key. Skew means that you are slanting a data at one side. So in case of Hive data unit related to skew keys, that you need to provide some columns on which if duplicates occurs, what Hive gonna do, Hive will split that data file in more smaller directories, in more smaller buckets, to avoid the execution and maintain the record behind the scene, so that it full table scan once it's been run, those kind of records should not be traversed again and again. This is the purpose of skew keys, because you're gonna define column and give column as a skew column, because you are expecting those column will be duplicated, and on those basis data should be moved into splits. So this is about skew keys. These are the basic data units. Let's take a look at that, how it's been stored in Hive and HDFS. So we have DB. DB is more kind of database, is being called as a DB. So inside database there are tables which gonna store against Hive HDFS directory. So once it goes in HDFS directory then split into subdirectories which are considered as a partitions, and then partition splits into this bucket file. So this is the hierarchy. We have read that. So if we see the below diagram here, we can see there are skew keys and unskew keys. All these metrics data units is being used, partition, bucket, skew key, unskew key is being used for faster execution. Unskew keys, the column which is not mentioned in skewness of the table, is unskew keys. This is the structure behind how Hive and HDFS is been communicating and how HDFS is been storing. So let's move to real-time example of a table, how a table is being going to use. Here we can see that country is a table. Inside it there are states, and inside it there are cities, which is being called as a bucket, and inside bucket there is data being stored. So this is all the storage mechanism gonna happen. So we have one example of table which I already extracted. Do a practical and run this on Hortonworks sandbox. So if I just click on that, it will show me the Ambari cluster is already running. I just need to log into Hortonworks sandbox. Let me log in so that everyone is on the same page. So I'm just providing the password here, try to log in. So I'm logging on Hortonworks sandbox. Before that, I need a data that need to be loaded. Data first of all in HDFS location, so that we can load that data in our table. So I just go there, user admin. So I will create a new directory that's named data1. Add, it will gonna add, go inside it so that I can load files from my Windows machine. I will be loading file from Windows machine directly to HDFS. So 5 different files I have loaded with the 5 different data sets. So now we have data in HDFS location. So if I just refresh it so that it's good, let's go back to the terminal. So we are on, and now let's import those files in our specified location so that we have access to that. Let's write this. Make sure that it's case sensitive, so we need to be very careful writing the name because Linux is case sensitive, so we need to be very careful writing exact path. So right now we need to check whether there is a directory or not in case of so we can create a directory here. So let's create a directory. The file in new directory. And now check that this directory just got something in it or it's still empty. So it's got some data in it. The file which we are expecting, it's already there. So let's launch in the Hive terminal. So run a command. We're gonna run a command with create database. So it's we can give any name. Temp Hive DDL. I'm creating database without any location. So that means it's not assigned with any directory yet. Let's check if the database is created or not. There is it, temp Hive DDL, which is we created. So now we have to use it because by default anybody logins is database is default database. This one is everyone's default database. So now if we're gonna create a table inside it, before we just go and take a look at again one thing which is important. Let's log into another terminal to see what exactly right now we have. So just want to show right now all the files is placed in user root table underscore ext directory. So we need to create a table. Let's pick a definition. This is the same definition which is we shown you on slide deck. So we're gonna see that whether this directory exists or not previously. No, it doesn't. So we just need to do a copy paste. I'm using pasting that definition here, so it will come there. So let me try to create that table. So I'm using temp Hive DDL database. Now if I do show tables, will only show me ext table. So if I want to see the DDL, show create table, show create table ext table. So it will show me the exact location where that has been there. So if I just go the directory structure, which I just checked that ext table was not there. There is a table ext, but ext table directory was not there previously. Temp ext directory was not there. So let's take a look at that. What behind the scene Hive did it. The temp ext directory is just created. So if we just view that temp ext directory, what's inside it, so that we will be crystal clear what's going on behind the scene with HDFS. Nothing in it. So let's go back to our Hive terminal. So we have created a table. Now next step would be loading data in it, because we already have a data. We will load the data according to the partition which we did. If we see there is a partition, country is the partition, and state is the cluster ID or bucket ID, and it will be divided into 32 buckets. But we will check that data size is not too big, so we will see that what exactly the partition gonna affect the directory structure. Here is the load command which I'm gonna paste it. So I just need to change the table name which I used it previously. I just need to change this one. Table partition data is this one. So I try to load the Pakistan data CSV file. Let me check the path of that. It's in table ext Pakistan data CSV. So I'm gonna give the partition as in Pakistan, which is virtual. So let's run this command. It's trying to load it, and it's done. So we just need to change the partition again with USA. It's America.csv. Let me check the name exactly. America.data.csv. So I will load it again. So it's done for USA. Let's try it for another country. United Kingdom. So exactly match the name there, United Kingdom. So this is done for 3 countries. We'll try for Australia and Canada. Or we just gonna check that show partition. So what exactly it shows to us. We already selected the database, so it will be in ext table. So it show me 3 partition. So if I just go back, and same way I'm gonna load the other files as well. If I just go, first of all, check this one, the directory I given that, it has 3 different directory, and it's created on the partition. If I go inside it, try to go inside it, so it's just 2. It show me the exact file which is being sent on that. So this is what I got. So this is how it's happened. But now we just need to, why I came here earlier, I just want to show you what happened with the source location of those files. From source location, those file has been moved to target directory. That's mean you are creating, I have created an external table. If I go to definition, it's created an external table. And remember, I mentioned that partition column will not be part of the column. It's a virtual column, so it's not part of that type. So whatever partition you are giving in it while loading the data, all the data associated to that one. So we just loaded 3 different datas. So we just try to query that with country from external table group by country. It does show me the records. So if I just go to Ambari and I just try to do it from Ambari, Hive views from Ambari, try to use that, it will show me more tabular form. Here either I select this one from drop down, or I just need to write a fully qualified name of a table, which is now I can check that table name is ext table. So I didn't loaded the other 2 files. Try to think that it's need to be, we can, whatever the required result is, we already seen that it's created a separate directory, moves the file from source location, so it is successful. Here is the tabular form of data. So if I go at the end, the virtual part which we are talking about, it's a virtual column, but in case of seeing that, you can see that it does contain that column. It will be seamless for user once they query that whether that partition is a part of the table or not. So this is how we loaded the data in the table. This is the partition, how partition behave to optimize the query. This is all about today's session. So if you want to ask any question, you can follow us on Twitter, ask there, Facebook, or YouTube comment on our channel. We will try to answer your question.